This lesson is on writing, interpreting, and using a linear model. So essentially, we're going to have story problems, and we are going to create an equation to help us to solve the story problem, and it's going to have several parts. So it's still going to end up in our y equals mx plus b form, our slope-intercept form. The b is the constant term, and that remains unchanged. So typically, if there is a fixed cost, or if there is an initial cost, that's going to be that B value. So that's the term that you pay this much up front. When you have something which is a rate of change or something per something else, like per month, per day, per year, per whatever, that's going to be what we're going to take times the x value. So that's our slope, our m. So we're going to use this now to write an equation and then to solve or use that equation depending on different information that we are given. Here's our first example. In Buffalo, New York, we had 2 feet of snow, or 24 inches. So we're going to focus on inches. And the reason we focus on the inches is because they, again, reference inches later. What we're trying to do is we're trying to write an equation to model this situation. So we know that at day 1, or when time begins, day 0 really, we already have 24 inches of snow on the ground. For every hour, 5/8 more of an inch will be added to that total. So a lot of people really struggle with, well, how am I supposed to write that as an equation? So think about if it was just 1 hour. I would take 24 and I would add 5/8 for 1 hour. And if I added that together, that would give me y, which is the snow depth after an hour. For 2 hours, I would still have my 24, but I would add 2 times 5/8 because each hour is going to be 5/8, and there were 2 hours. And then for 3 hours, it would be 24 plus 3 times 5/8. And so if I'm using x hours, then it would be 24 plus 3, times x times 5/8 equals y. Now that looks a little bit funny because that's not how we normally write it. So I would write it with the y first, 5/8 times x plus 24. So it's the same information that I had here, but it's y equals 5/8 x plus 24. Now they want me to graph the equation. We've already worked quite often with graphing equations, so I went ahead and graphed it for you. Notice it went through here at 24 and had a slope of 5/8. So this would be the graph of the equation. Notice that the rate, or the snow, is increasing at a linear rate. For the next part of the question, we're trying to use that equation, which again was y equals 5/8 x plus 24, to do some predictions. So the first one asked for us to compute the depth of snow after 8 hours. Remember that x represented hours and y represented the total snowfall. So if they're giving me hours, I'm going to replace x with 8. So I'm finding the depth of snow, which is y, by plugging in 8 hours. When I take 5/8 times 8, I get 5. Oh, that's supposed to be a plus, sorry about that. And I end up with 29, which means after 8 hours, the snow depth is 29 inches. And again, I would probably write that as a sentence. For the second one, notice they don't give me hours, they give me snow depth. And so for the second one, I'm still using this equation to predict, but I'm replacing y with 31.5 because they're giving me snow depth and they're asking me to find how long the storm lasted or how many hours, x. So for 31.5 equals 5/8 x plus 24, I will subtract 24 to get 7.5 equals 5/8 x, and the simplest, fastest way to solve this is to multiply by the reciprocal, and I would just get my calculator out on this one. On this side, I would have 7.5 times 8 and then divided by 5, which gives me 12. And on this side, notice everything canceled out to give me x. So it would be 12 hours is how long the storm lasted to have a total snowfall of 31.5 inches. For the next one, we're talking about Joe and his college savings account. So he had $1,000 in his account already, and then he decided he's going to put $120 per month into his savings account, and we want to write an equation first. So again, the amount that he started with is the 1,000. So that's going to be the b value. So remember, we're always going to write it in slope-intercept form. So it should be plus 1,000 because that is not dependent on how many weeks. This is how much he started with. He's going to put in $120 per month. So whenever we see that per there, we know that's a multiplication thing. That's going to be our rate of change. And so our formula would look like this, which would be he started with 1,000, and then for every month, we're going to add $120. To graph that equation, it's going to look like this. So again, it's starting at the 1,000 here, and it's going up $120 every week, or sorry, every month. Now we're going to use that equation, and again, I'll just rewrite that equation for you to do some predictions. For the first one, we're computing the amount of money in Joe's account after 6 months. So again, X represented months and Y represented total balance. So for this one, I'm simply replacing X with 6. And if I take 120 times 6, I get 720. And if I add that to 1,000, I get 1,720. So my answer is the amount of money in Joe's account would be $1,720. And if I had more room, I would write out that entire sentence. For part D, now they're giving me an amount to shoot for. So that would be my Y value is the amount in the account. So I need $3,160, or Joe does, for the down payment on a car. And we're asking how many months is it going to take him. So again, we'll solve just like this. Wow, I have a problem with that plus sign. I'm going to subtract 1,000 to give me 2,160 equals 120x. I'm going to divide by 120, not 120x, just 120. I'm going to get 18, which means after 18 months of savings, Joe will have enough money in his account to purchase or to have the down payment on his car.